I'm going to describe and demonstrate how to use a simulation that goes through step by step the determination of Maxwell relations if we start with an exact differential. So this is a view of what the simulation looks like. It's located at this link, and what I'm going to do now is go to the simulation. So it says click one of these equations to get started. So let's look at the first one, and it's just reproducing it. Now the idea says click the state variables you'd like to hold constant. So for example, if we want to hold the volume constant, then change in du is just TdS, which means the partial view with respect to S at constant volume, because we got this by holding volume constant, is just temperature. And now we can continue, and now we look at the other variable, the same thing now, the change in U. The change in volume at constant entropy is this partial derivative. So we have two partial derivatives. And then we take advantage of the idea that we have an exact differential. We're differentiating U with respect to V and S. And it doesn't matter which order we do it, whether we differentiate first with respect to V or we differentiate first with respect to S. Both cases we have this second derivative. So these two are equal. And what we're going to do is substitute du dV becomes P, du ds becomes T, and so then this is a Maxwell relationship, and the idea is we can reset, select another one of these equations and go through that step again to derive a different Maxwell relationship.